Hello and welcome. Today's video lecture will focus on budget constraints. We'll begin with a definition. A budget constraint is a graphical representation of all bundles that exhaust the consumer's income at given prices. For example, if the consumer's income was $200, a budget constraint would represent all possible combination of two goods that the consumer could purchase worth $200. Let's proceed with an example. The example reads, a consumer has a budget constraint of $240. Good X costs 3 and good Y costs 5. Draw the budget constraint. So in this example, the budget constraint will graph all the combinations of X and Y that will exhaust a budget of $240. We will begin by finding the intercepts. First, we find the Y-intercept. The Y-intercept represents the amount of good Y we could purchase if we spend all our budget on Y. So if we have $240 and Y costs 5, how much Y can we purchase? We could set up an equation, as shown here, and solve for Y. So if we spend all our budget on Y, we are able to purchase 48 units of Y. Next, we find the X-intercept. The X-intercept represents how much units of X we could purchase if we spend our entire budget on X. So if we have $240 and X costs 3, we could set up an equation as seen here and solve for X. So if we spend all our money on X, we're able to purchase 80 units of X, and here's its intercept. Now that both the X and the Y intercepts are found, we're able to draw the budget constraint. It is important to note that the slope of the budget constraint is called the MRT, or the marginal rate of transformation. Mathematically, the slope is found by setting up this equation, negative price of X over price of Y. Price of X is 3 and price of Y is 5, so the slope in this example is negative 3/5. We next move to part B. Part B reads, suppose that the given constraint, the consumer maximizes her utility by purchasing 25 units of X. How many units of Y will be purchased? To answer this question, we first need an equation that summarizes both X and Y and the budget. And this is the equation we could use. M, the budget, which is $240 in this example, is equal to the price of X times the quantity of X plus the price of Y times the quantity of Y. Given this equation, let's fill in the information we know. We know the budget is $240, we know X costs 3 and 25 units are purchased, and we know that Y costs 5. With the information filled in, we have a one variable problem and we could solve for Y. Here we simplify algebraically, more simplification, and solve for Y to be 33. So in this instance, utility is maximized when 33 units of Y are purchased and 25 units of X are purchased. These points intercept at this point on the budget constraint, and a convex indifference curve is drawn. As a reminder, an indifference curve is a set of all bundles on which the consumer is indifferent. We next move to Part C. Part C reads, now suppose that she is willing to spend $300. So the new budget moved from $240 to $300. Draw the new budget constraint. For this problem, we are going to assume both goods are normal, and we will have to show the range of the new utility maximizing point given the new constraint. So let's start by drawing the new constraint. So first, to do so, we will find the intercepts. So to find the y-intercept, we ask this question. If we spend all our budget on Y, how much Y can we purchase? So our new budget is 300, Y still costs 5. Solving for Y, we get 60 units. If we spend all our money on Y, we can afford 60 units of Y, and that becomes our Y-intercept. Next, we find our X-intercept. Remember, X-intercept represents the amount of units of X we can purchase if we spend all our money on X. We now have $300 to spend, and X still costs 3. So if we spend all our money on X, we can afford 100 units of X, and that becomes our X-intercept. Given our two intercepts, we can make a line. What is noticed is that both the red line, the previous budget constraint, and the green line, the new budget constraint, are parallel. That means they have the same slope or the same MRT, which is -3/5 in both cases. They are the same because prices have not changed, and we know that MRT is defined by the ratio of prices. With that clarified, let's move on to the second portion of Part C. The second portion asks us to find the range for the new utility maximizing point. So to find the range, I will start with my original utility maximizing point and draw coordinates. As you can see, the coordinates are labeled by N and I. In this case, N will represent a normal good and I represents an inferior good. We will soon see how the new range of utility maximizing point depends on the normality or inferiority of goods. A normal good is a good a consumer will purchase more of when their income increases. For example, if I become richer, I may choose to purchase more Wagyu steak, which is a normal good. An inferior good is a good I purchase less of when my income increases. For example, if my income increases, I will purchase less instant noodles, which are an inferior good. In this problem, we are told that both goods are normal. That is, when my income increases, I will choose to buy more of Y and more of X. And that is by definition a normal good. Given that information, I could find the range. On the x-axis, I will buy more because it is a normal good. On the y-axis, I will buy more because it is normal good. Since both are normal, the range is given by this section. So my new utility maximizing point will fall somewhere here along the budget constraint. What we can conclude is that we will buy more of Y and more of X. That's it for this tutorial. Thank you for watching.